Welcome everyone to the next session of the ESMAR conference, where we're going to be talking a bit more about automation with this very broad other label on it. We have a number of speakers across this topic, but the first one is going to be Neal Haddaway talking about the GSscraper package.
In the next 7 minutes, I'm going to introduce the R package GSscraper, which is for scraping search results from Google Scholar. Google Scholar is useful as a resource in evidence syntheses and meta-analyses because it's a web-based academic search engine that's free to use. It's also very easy to use, which is why it's so popular. There's no human selection of the content, so unlike bibliographic databases, any information that looks like academic content is included in Google Scholar, and that's regularly crawled from the internet, so it's very up-to-date, more up-to-date than many bibliographic databases because it doesn't require manual inclusion. It also identifies grey literature, things like preprints, and has been shown to be a useful addition to databases and other searching in systematic reviews. It's not suitable as a single source of information in systematic reviews or other evidence syntheses for a number of reasons. Firstly, it doesn't support full Boolean search strings, only basic strings. You can only see 1,000 search results, and the order of those search results is unknown. So if you have more than 1,000 search results returned, you can only see the first 1,000 and you don't know why those 1,000 are being shown. It's some black box ranking algorithm. Excuse me. There's also no bulk export from Google Scholar, which makes it difficult to integrate into review management platforms. And there's a very sensitive bot detection algorithm, which makes it difficult to do anything in a patterned way. One of the solutions to these kind of problems with grey literature is web scraping, which is the extraction of patterned data from information on the internet. There's a range of different ways of scraping information, from the human-driven copy-paste to more technical machine learning type approaches. But the most common perhaps is HTML parsing, in which you extract chunks of content based on unique or repeated signatures in the HTML code. Within Google Scholar, you can identify each result in a page of results by the tag class equals GSRI within the HTML code. And for every one set of search results, there is one tag, which makes it quite easy. On the left, you can see the search results in Google Scholar, and on the right, you can see the HTML. And there's an entire div with the class GSRI, and we can then extract each of the pieces of information within that search result using this code. So I've produced some functions within GSscraper. One is buildGSlinks, and this allows us to build a Google Scholar URL that takes you to a real page of search results based on patterns in the URL itself. So you specify the terms exactly the same as you would for the advanced search, and it generates functioning URLs for pages of search results. So you'd input the information as you see on the left, and the function on the right allows you to specify how many pages of search results you want brought back, and it will provide, in this case, 100 URLs for the first 1,000 search results. The next function, saveHTMLs, saves these URLs, or any given URL, from Google Scholar, and it uses or any web page in fact, it uses two methods to avoid bot detection. The first is a consistent pause between calls, and the second is specifying a multiplier to multiply this pause depending on the response delay of the server. So if the server takes 1.2 seconds, it multiplies this by the pause and waits that long between the next between the current call and the next, and that just introduces some randomness. So if we see these 5 URLs given here, the function would pull back the HTML pages for those 5 URLs, waiting, in this case, 5 seconds multiplied by whichever server delay happened at the time, and it would save them locally. The next function is to get the information out of those HTMLs. It uses a subfunction called split by div, which breaks the HTML into chunks of code, each starting with div space class. It then uses regular expressions to extract each set of search results in a single chunk from within an HTML file. And it extracts specific citation information based on the position of the subchunk, so the subset of text within each major result chunk, based on its position. And we know its position because Google Scholar is consistent. And the output is a data frame where each line is a search result and each column is a title, author, description, year, link, or DOI. And the DOIs is really useful because the DOIs are more often than not embedded within the publisher URL. So we can extract that information that allows us to very consistently link to other systems like Crossref. So this code here shows the function that's used to extract titles from each search result within the HTML. And it uses a few substitutions, either global substitutions or single substitutions, to remove field codes to make it easier and more consistent to have the text rather than the embedded code as well. And the final function is save and scrape Google Scholar, and that's just a wrapper that takes the building, saving, and scraping functions and pulls them together into one function. So here you can see you just input the terms that you want in your search, and then you can create a global object, in this case info, which is a data frame of as many search results as there are in your HTML files. And this just looks locally within your working directory for any HTMLs and extracts all of the relevant information that's saved as part of that function. So in this case, we're specifying 30 pages of search results, which would give us 300 results. There are some challenges though. Despite the pause and back off, the bot detection is still an issue. So there's a need to tweak that a little bit and try to improve it. I've tried using IP stuff, but it's much harder for me. I'm not an expert in that. Another issue that is that not all of the links that are provided by the publisher contain DOIs, but I was surprised by how many did. Future work is to build a link to Crossref. I've done a bit of work on that, but it needs tweaking and improving to validate the records that are extracted. Some of the other resources that already exist, like Publish or Perish, get much of this information, but they don't get the description or the DOI. So that's quite a unique improvement, I think. I also want to improve the bot evasion and allow exporting as RIS format files, probably using synthesizer from the metaverse. Thanks very much for your time.
Great, thanks, Neal. A really interesting presentation. Do we want to do questions now, or we save them all for the end? Because I have some pressing ones, and I don't know if anyone's asked them through Slack, but I don't think so.
We have been saving them until the end, actually, but yeah, maybe if we can save them to the end.
Okay. Sounds good. Excellent. So our next presenter then is Wolfgang Viechtbauer, who's going to be talking about automated report generation for meta-analyses.
All right. So hello, everybody. My name is Wolfgang. And I will now be talking about this idea of generating reports automatically using the metafor package. So to start, let me just say a few words about metafor itself. So this is an R package for meta-analysis. It grew out of code that I wrote for my dissertation research, and then eventually it turned into a full R package, which I've been updating ever since. And below here are some relevant resources related to this package. So what is the usual workflow when we are conducting a meta-analysis? Well, we first have to find the studies, of course, and we've been hearing several talks about how that can be automated. Then we have to extract information from them. Then we can compute effect sizes, so outcome measures, which we can then meta-analyze with, let's say, a random effects model, which we can then we can do some further analysis steps, like looking at outliers, drawing some pretty pictures, maybe running some checks for publication bias. Eventually, we need to write this all up And then the very last step is, of course, to send the paper to Nature or Science and get it rejected. Okay, so let's go through an example here of a meta-analysis. This is on the BCG vaccine. That's a vaccine against tuberculosis. And so if you want to find out if this vaccine actually works or not, you have to do a study. And so you take a group of individuals which get the vaccine, another group does not, and then you look at the infection risk in the two groups. So these are the results from one of these studies. So we have an infection risk of about 3.25% in the vaccinated group, almost 8% in the control group. So risk ratio of 0.41, so indicating a quite lower risk in the vaccinated group. Then we have the log risk ratio. So that's what we really need for the meta-analysis, and then the corresponding sampling variance. Now, in total, 13 trials have been conducted on this vaccine, and here are the results from these 13 trials. This data set is also part of the metafor package. And so here what I'm doing is I'm using the ESCalc function to compute the log risk ratios of all of the studies and the corresponding variances, which I can then feed into the RMA function, which is one of the main model fitting functions. And then I can look at the output. So I see how tau square was estimated using REML, restricted maximum likelihood estimation. I get the estimate of tau square, I squared, the Q test for heterogeneity, the estimated average log risk ratio, and the confidence interval. So I can start to make sense of this output. Then I can draw some forest plots, funnel plots, maybe do some checks for outliers, and run things like the rank and the regression test for funnel plot asymmetry, which may be indicative whether there's publication bias going on. So that is the usual workflow. And so there's a function now in metafor, the reporter function, that is essentially automates this process. So it writes a report for you that describes the statistical methods used, and it provides the results in terms of natural language. It includes a forest and a funnel plot. It gives references for all of the methods used, and you can either get HTML output or PDF or Word document. So let me give sort of a demonstration of this. So here I'm loading the metafor package, then I'm going through this process of computing the log risk ratios, and again, then fitting a random effects model, and here's the output. But instead, what I could do is run the reporter function. And so this is what it looks like. So I get this analysis report, and it tells me that log risk ratios were used as the outcome measure. A random effects model was fitted. How was tau square estimated using REML estimation? It gives references for the Q test, for I squared. There are some rules as to how the function determines whether there may be potential outliers, and this is explained here. And then it describes tests that are done, like the rank correlation test, the regression test, and then you get the results. So 13 studies were included in the analysis. What was the average estimated log risk ratio and the confidence interval? Then you get the forest plot. Then you get the results from the Q test. And so here there is heterogeneity, apparently. So the test is significant, I square is very large. So you get a prediction interval. There's no indication of outliers here. Then you get the funnel plot, and neither the rank correlation nor the regression test indicated any funnel plot asymmetry. Then some notes, references. So this is what it looks like. So this is what the function can do. Now, this is not complete yet. Right now, the results are provided in terms of the outcome measure that you put in. So here, log risk ratios, but typically we would want to back transform this to risk ratios. So the possibility of back transforming the results, I would like to add this. At the moment, Reporter does not work yet with meta regression models. So this is something I would like to add and to extend the function to work with other model objects, like the RMA.mah function is for the mental Hensel method, while right now Reporter doesn't work with this, but this is to be added. And maybe some more customization, maybe some explanatory footnotes. So there's several things that I would like to add. But even right now, I think this function is quite useful for while teaching purposes, learning purposes, and while basically for automated report generation. All right, thanks.
Great, thanks so much, Wolfgang. That sounds like a really, really useful function. I can't wait to use it in my own research. So we're halfway through the session now. We have two more speakers, the next of whom is Emily Hennessy, who's going to be talking about promoting synthesis-ready research.
Hi, I'm Emily Hennessy, and today I'm going to be talking about promoting synthesis-ready research. So before I begin, I do want to mention that this was an idea and paper that was developed at the 2019 Evidence Synthesis Hackathon, and we do have a preprint available. I want to acknowledge all my co-authors on this truly collaborative endeavor. So before we dive into the topic, just a brief intro to the terms. First of all, synthesis ready is the term that we use to describe a study. It's metadata and data that can be readily and accurately used in an evidence synthesis. So those would be scoping reviews, systematic reviews, meta-analyses, or meta-reviews. Anything that is part of that evidence synthesis umbrella would be relevant here. And so really the idea for this paper is primarily generated from this underpinning of the open science principles. And that is really having increased rigor, accountability, and reproducibility for research by having transparent and accessible knowledge, study data that is shared across scientific networks. And so that's really important. You know, those of you that are here that are learning about doing evidence synthesis in R, you would not be able to do that if people did not share their data and share it accurately, share correct data. And so, you know, an additional principle that set of principles that really helps research be synthesis ready, in addition to thinking about it as open science, following open science principles, is this idea of research that is findable, accessible, interoperable, and reusable. And so from our perspective, open science is a great foundation, great groundwork, but if you're really approaching this from the view of making research fair, you will also be making your research synthesis ready, and therefore it will be much easier and for evidence synthesis to use, and it will be a better use of existing resources. So the goal overall is better scientific evidence, a very lofty endeavor. So in addition to you know, improving science as a whole, there are some specific advantages for you in terms of not only operating from an open science perspective, but operating in a way that will make your research synthesis ready. So if it's synthesis ready, we consider it more likely to be identified by people that are doing a literature search for your study. If it's, you know, lost somewhere and not archived well, then it may be very difficult to be identified and used in an evidence synthesis. And what that means kind of in the long term is that could open up many potential opportunities for future collaborations of individuals that are interested in the same topics you're interested in, potential for resource sharing because of those collaboration, as well as increasing kind of your lab or your team's recognition internationally. And finally, kind of the hard coin of academia is increased citations. If your study is identified and used in an evidence synthesis, that's a citation that you did not have before that point. So from the perspective of making your research synthesis ready, we conceptualize that as a kind of a process that has to begin at study design and continue throughout the project life until you're ready to share it. You don't want to think about making your research synthesis ready when you're ready to publish the paper and share the data. You really want to build that into the initial piece of the study design in terms of making sure you have a study that's been pre-registered and that follows a protocol. However, today's topic, we're really going to be primarily focused on this idea of study dissemination and some tools you can use to make sure that your research is highly likely to be found and accessible and usable by evidence synthesis. So just as a brief introduction, it's really important at the initial study design and study conduct phase to use transparent and reproducible workflows. Because doing all of these steps well will make the later steps of producing synthesis-ready research much, much easier. When it comes to study dissemination, we have kind of 6 primary tips for ways to help make your research more findable. And so initially, having some sort of unique permanent identifier that's tied to both your data and your study publication, such as a DOI, for the data and the publication, and also for authors, making sure to link, include the ORCID ID with the submission, as institutional emails can often kind of be obsolete. It's really important when registering on different databases or journal websites to use consistent author usernames so that folks who are interested in your work can easily find you and the work that you do. And finally, especially if you're sharing data separately from your published manuscript, to include a data availability statement along with your manuscript so that anyone who finds your manuscript knows exactly where to find your data and how to get there. It is really important. And so, another highlight of doing this is that your data can also be cited in addition to your published version of your manuscript. So the next steps are really when thinking about study dissemination, how to maximize the reach of your study, that it will be identified in literature searches for your research. So if you have data stored in a repository, make sure to use tags that will tag kind of the topic of your research. And we actually suggest using an R package lit searcher that's developed by Eliza. And there's a whole website and vignettes that go along with it, but essentially this is an evidence-based way to use R to generate keywords that can be used in the title and the abstract, and those journal keywords that can help researchers to identify your research much easier than words that you might think of on your own. Finally, in terms of really making sure that others can reuse your data in their evidence synthesis, it's really important, and that you get credited for it. It's really important to think about licensing your data. We don't have the time to go over all those options now, but there are several websites, several organizations that will give you more information on that. And we actually chose for a recent study the CC BY 4.0 license, which tends to be used most commonly in sharing primary study research. Along with that data license, you want to make sure that you've included, wherever you share your data, information such as a data dictionary or variable crosswalks, and a README file which goes through exactly what readers and users of the data can expect to see when they have your data in hand. Lastly, in terms of thinking through where you want to archive and share your data, there are lots of different options. We have a list of them here. In the paper, we actually go into the advantages and disadvantages of each, so I encourage you to view those. The best option would be a non-affiliated repository, as it's likely the most findable, provided it's free as well. So be sure to look in our resources for that. And so lastly, this is just the overall roadmap as a reminder, but please feel free to read the paper and the example that goes along with it, because that will give a lot more examples around how to do this for your own research.
Great, thanks, Emily. And then our last presenter is Kaitlyn Hare, who's going to be talking about identifying duplicate papers.
So yeah, today I'm going to be talking about a tool I built called ASySD, which stands for the Automated Systematic Search De-duplicator. And I built this really to help me identify duplicate publications within my systematic review searches. So the problem for systematic reviewers is that we have to try and collect as much of the available evidence as possible. And this means searching across multiple databases like PubMed and Web of Science. The problem is that we're going to encounter duplicates that come into our systematic review workflow. And if we don't identify them at an early stage, it means that we're going to waste time later on extracting data from the same paper twice. And in the worst case scenario, we're actually going to use that data towards our meta-analysis, and it's going to impact on our results. So it has the potential to be a really serious issue. So you can see on the right-hand side here, I've just got sort of two examples of a paper that is the same, but is across different databases. So you can see there's subtle differences in the way the author is formatted, the title, little subtle differences in the pages and things like that. And these differences are very obvious to a human. Looking at these, it's very obvious that they're the same paper, but on a really large scale, if you're working with, in my case, I was working with a systematic search that was over 200,000 papers. So to manually go through them all is impossible. And I was looking for an automated tool to help me do this. So in our lab, we work with really large systematic review data sets looking at animal models of disease. And typically, how we've deduplicated our searches to date, we've used a combination of EndNote, which has an automated tool, an automated deduplication function, and also a bit of hand searching. So we would tweak the filters in EndNote to maybe match just on title, and then go through those duplicates by hand. But as I said, it wasn't really fit for purpose in my situation. So I took previous systematic review data sets that we had in the lab, and I put them into RStudio, and I started trying to work with the formatting and sort of clean the data in a way that I could try and get the fields to match better. So I worked on the DOI formatting, the author formatting, pages, things like that. Then I discovered this R package, record linkage, which has actually been around since 2010. And it allows you to link records together based on a number of criteria. So you can have blocking criteria where, for example, the title and pages have to match 100%. And you can also, another thing this package does is you can compare the text. So with every field between the papers, it will compare the text on a scale of 0 to 1. So if it gets a score of 1, it's really similar, and obviously 0, it's not similar at all. So I developed these blocking criteria, and once records have been linked in this way, obviously a lot of the linked records won't be duplicates. For example, if it just matched on title and volume, or let's say year and pages and volume. So I developed additional filters to basically, using the textual comparison, I basically just developed these using a heuristic approach. It was a lot of trial and error. I know there's probably some machine learning approaches that could be applied here. I'm not particularly skilled in them. So this was just really a trial and error approach. And then when I got to a situation where I was happy with these filters, and I was sure that the papers that were the linked records that were being passed through were definitely duplicates, I choose a record within those pairs to remove. And I keep the record with the most information. Another aspect of this is, because our lab is moving towards living systematic reviews, we need a way to be able to tweak how the algorithm will decide which record to remove. So in living systematic reviews, you maybe want to keep the old records in your database over the new ones that are coming in. So I built in a way to be able to change this criteria depending on your systematic review design. And I also built all of this workflow into a Shiny application for people to use, because I didn't want it to only be accessible to our users. So I wanted to compare how ASySD actually performed to the typical tools that people use for automated deduplication. So as I said, we in our lab typically used EndNote. So I compared it to EndNote's automated deduplication function, which is the default setting for EndNote. And I also compared it to a tool developed at Bond University. It's part of their Systematic Review Accelerator suite of tools. And I thought it was a good comparison because it's also a web application that you just plug your systematic search into, and then it spits out a unique set of records as a result. I collected 5 databases from collaborators who well, these data sets had not been seen by ASySD, so I wanted to, make sure I was testing it on unseen data sets of various sizes. So the smallest one is under 2,000 records, and the largest one was nearly 80,000, and different duplicate percentages as well within these searches. And overall, ASySD outperformed EndNote and the Bond tool. It had really high sensitivity, which means it could detect the vast majority of duplicates. It had a really low false positive rate, which was a really important factor for me because I didn't want it to remove duplicates incorrectly. And it was also pretty fast as well. In terms of speed, it was quite comparable to EndNote, whereas the Bond tool, sometimes you had to leave it running, for 24 hours plus on your computer. So the next steps for ASySD really are to disseminate the tool via this conference and hopefully publish a paper on it as well and get it out there a little bit more. I want to integrate more import formats so it can work with Mendeley, Zotero, and other reference management software, and hopefully integrate it with systematic review workflows and platforms. I also want to scale up capacity so that it can work with larger data sets, because at the moment, the Shiny app is limited at around 50,000 records. So this is just a sort of technical issue. So I'm trying to work on this to make sure it can improve. And hopefully as well, I want to make it into a proper R package, because at the moment it's just functions. I've never developed an R package, so this is the next challenge to build this. The code underlying the tool is openly available at GitHub if anyone wants to have a look. And over here, I've just got a QR code if you want to visit the Shiny app website as well. And this is just a little screenshot. I didn't want to do a live demo in case something went wrong. But you can see, hopefully, you upload your files here, you go through to the deduplication stage, and you can go through automated, and there's a bit of manual deduplication as well if you want, and then you can download your data. So thank you. I'm happy to discuss in more detail in the panel session.
Brilliant. Thank you very much. And thanks to all of our speakers. We do have some questions for you while we have you on the line. So just going first to Wolfgang, someone wrote in to ask what the format of the output of Metafor Reporter is going to be, and whether it's going to be possible to nest it within a larger or markdown document.
Yes, happy to answer that. So I guess I can again share my screen maybe. So let me go back here to RStudio. So if you look at what it says here when you run the reporter function, it tells you that while it's generating the report in some temp directory, but this is where you actually find the report, and it is generating an R Markdown file indeed. And so this is in that directory. So you can just actually open up that report, and this is what it looks like. It's just an R Markdown file, which you could then further edit, copy it somewhere else, and then make this part of your paper. So this is how it works.
Fantastic. And just one related follow-up question then, is a function like this going to have any impact on plagiarism detection software if we're using the same boilerplate text in lots of reviews?
So yeah, I'm starting to suspect we will see a lot of papers with very similar phrasing in the future. Actually, so personally to me, I think this is perfectly fine, because while I wrote this function so that the report includes all of the information that at least I think, but I base that also on what other people have suggested, of course, what should be included in the results section of a meta-analysis. So for example, tau square is explicitly reported. You always get a prediction interval if you're working with random effects models, which is still not common practice to always report a prediction interval. So I'm trying to also use this to implement best practices. And so if people just use that report, I think this would actually, well, you may want to rephrase it a bit because the language is a bit stilted. I have to use a lot of passive voice. I cannot really customize the results in terms of, well, what is this meta-analysis about? The BCG vaccine, for example, like we're talking about a vaccinated versus not vaccinated group. So it's all very abstracted. So that would still then, I think, require some further work if you are going to incorporate this into your paper. But I think the basic structure is fine. And personally, I think, well, yeah, not a big deal if people actually make use of this. That's the whole idea, of course. So.
Yeah, yeah, and I really like the way that you are trying to use it to influence best practice, so that all of these things are being regularly reported. Brilliant, thanks, Wolfgang. So we just had a question as well for Kaitlyn around the deduplication. So how do you build in capacity for working with errors? So Neal has pointed out that some DOIs are wrong in quite a large percentage of cases, and is there any kind of redundancy in the software to deal with that?
So there isn't so far, but I know this is actually an issue as well, because we've been working on a project trying to collect and classify COVID publications, and we use this tool to deduplicate as those records come in, and a lot of them are wrong. I think because the research is coming out so quickly. So we're now trying to build in some sort of validation, maybe with cross-ref APIs or something, to check that the DOI is correct. But thus far, we haven't got a solution.
Cool. At least it's on the horizon anyway.
Yeah.
I had a question for Neal that he's actually answered in the Slack chat. And just a reminder, if you do want to ask questions of any of our presenters, just to put a message in the relevant section of the questions for presenters channel on Slack. So Wolfgang, just one more question for you. Do you have any ideas to implement or follow recommendations in the literature, for example, on the use of tests for funnel pod asymmetry? It references the Stern et al. Paper in the BMJ. I'm not entirely sure what they're getting at, but
yeah,
whether, you know, if there's...
Not 100% certain either. I would have to look at exactly what is recommended in that paper, but if it's I think I may know which paper they're talking about. So it's about like choice of axes, maybe what to put on the X and Y axis in a funnel plot. And so actually that's what the funnel function sort of does by default anyway. So in that sense, maybe I am already kind of following those best practices. But yeah, while there can be differences in opinion as to what actually the best practices are, and I'm happy to hear input as to how the function should actually sort of behave and what it should provide and so on. So.
If people have opinions on this, what's the best way for them to feedback to you on that?
Through, well, either email or GitHub. So Metafor is on GitHub, and so you can always raise an issue there.
Perfect, brilliant, thank you. I just had one question for Neal, which was in terms of reporting the searches done using GSscraper. So because they're inherently unreproducible, how do you recommend people document them?
Yeah, that's a really good point, Luke. Thanks very much. I think it sort of breaks down into two issues. One is being very transparent about what you did so people can at least see what you've done. And the other one is replicating what you've done using that transparency. And what you can't do with Google Scholar is replicate, because the content changes over time in a way we don't know. And also the ranking algorithm is fundamentally unknown, so that you don't know why you're seeing those 1,000. And it seems that different people find different first 1,000s. So the replicability is a problem. That will always be a problem. But tools like Google Scholar, web scraping, even just manually saving each page of search results as a PDF or an HTML can at least get that transparency box. So you say, well, this is what we found. And this is how we then went about screening it. I'm in the process of building into the GSscraper app I think it might already be there, reporting function, so that when you perform your search, you get a little text report that says what your search terms were, what the returned URLs were, the date, and how many results you got. So that is automatically saved and in a consistent format. Yeah, it is a problem, and that's why everybody, bar a very small number of people, recommend that Google Scholar is only a useful additional resource, a way for mopping up studies that might be missed by other resources. But yeah, it's a good point.
Thanks, Neal. And I just had one final question. I don't think I've missed any in the chat, but do just share with me if you see any. But one for Emily, which is just what would you say to primary researchers who are worried about scooping or potential malicious reuse of the data if they share it and make it openly available?
Yeah, that's a good question, Luke. And I think it's something that a lot of people worry about, and it's something that I worry about as a primary researcher. And I think, from the perspective of, doing good science, thinking through how to share your data from the beginning is a key piece of making sure that people aren't scooping you. That's why pre-registering a protocol is a really good idea, because that kind of puts out there that that's your work that you're working on. And then, really making sure to license the data before it's being shared should prevent against people kind of stealing that data from you. But yeah, it's definitely, I think, an area where a lot of people are concerned. And I know you and I have had discussions about this. I don't know if you want to offer additional kind of feedback on that as well, Luke or Neal.
Yeah, or if anyone else has any thoughts as well.
I had a question, a follow-up question actually for Wolfgang, in terms of, this is such a wonderful reporter function. I'm really interested in how it could be used as maybe a teaching tool, an education tool for folks who are learning how to do meta-analysis. And, what are your thoughts on kind of using it in that way and kind of bringing it to like the education workforce in order to educate younger scholars in how to report meta-analyses?
That's a really good question, because that's also one of the intended purposes of this function. So to really teach people like how they should write up their results, right? Like in a lot of courses, so I teach a lot of courses on meta-analysis, and then we go through like interpreting the output, but there's still this gap as to, well, how should I really then write up my results? Okay, you can read some meta-analyses, how other people have done it, and model your own write-up after that. But that actually is sort of one of the ideas behind this function, that it shows you a way of how you could write up your results. And then maybe with a bit of tweaking, making it sound a bit more elegant, but yes, that's exactly the idea. And I mentioned this sort of to-do item that I have is to have an option to switch on footnotes. And the idea is that what it will do is then, because right now the description is still somewhat technical, right? It talks about like tau square, the Q test for heterogeneity and so on. So it does assume that the reader, the consumer of that report, has some familiarity with these concepts. Well, then if you switch on this footnote option, what I'm thinking it will do is it will explain these things actually in footnotes. So what is the regression test for funnel plot asymmetry? And so it will actually provide a little bit more of an explanation for each of these things. And so that would make it even more useful, I think, as a teaching tool. And that's something that is also on my to-do list.
You're going to be busy, Wolfgang. So I think I've addressed all the questions sent in. So unless the presenters have any other questions for each other.
I just had a bit of a comment on the open fair principles and that kind of comment about being scooped. I think if you see it holistically from inception of a study idea, sorry, my voice is going a bit, inception of a study idea, then by being open and publishing an intent through a protocol or a registered report, you're laying the groundwork not only to say, hey, this is my area, steer clear, or maybe not to say that, but instead, this is what I'm intending on doing, give me feedback, let's collaborate. And then the idea of scooping sort of disappears. I think you said this, Emily, really, but I think when you see it holistically as a whole process, and this comes back to the concept in open synthesis of open collaboration, I think that's a really important one, that if you were just open about your data and not any other stage, then yeah, the risk of being scooped is a problem, but it's about sort of changing institutional practices, and it's very challenging, and particularly is worth thinking about the risk of exacerbating existing power imbalance where it's often people who are marginalized or at risk who have the most to lose by being open. And so I can imagine there are situations where PhD students or early career researchers want to be more open, but they're perhaps later career stage supervisors are quite against it. And then that's a battle and they don't feel they have much power to be able to do it. So it's definitely a problem, but I think there's stuff to work on institutionally to support individual behaviors as well. I think it's holistic from a procedural circular point of view and holistic from a point of view of multiple levels, everybody in the community trying to embrace it.
Yeah, thanks Neal for that follow-up. It reminded me that when we were looking into this issue of scooping, some of the research that has been done has actually suggested that people who share their data sets are more likely to find kind of new collaborators. And what ends up happening is that people who want to use their data reach out to them and ask them questions and do want to kind of collaborate rather than scoop data. So you do find kind of by doing that, a broader network of a community of researchers. So yeah, thanks for reminding me of that, Neal.
Excellent. So I don't think we have any further questions, so I might just wrap up this session now. So just another massive thank you to all our presenters today. Some really interesting topics and talks. And yeah, just a reminder that if you do have any follow-up questions for presenters, do reach out to them either via the Slack or their institutional addresses. And yeah, thanks very much, everyone. I think I've covered everything. Yeah, thanks very much. We'll be back at 3 p.m. GMT with quantitative synthesis session 2A, just to add. Cool. Thanks very much, Luke.